With the coming of AI, we've all been disrupted. Fact is that AI is going to automate routine tasks, but will create a demand for high level of thinking. So to future-proof yourself as a data engineer, you have to think about what higher level of thinking am I now going to give the world of AI.
How do you differentiate between a good one and a great one?
A great engineer is one that works themselves out of a job. The great data engineer will build for self-service. They'll build platforms and solutions for others to build on. Your success is measured in BAU. It's not about how great you built the solution. It's about the end user.
My advice to the data engineers out there, it's not like you want to get into AI, it's how you can bring AI into your world.
Hi everyone, welcome to What the Tech podcast, where we simplify complex AI and technology concepts, explore real-world applications, and cover thought-provoking conversations on the future of technology. In today's episode, we're going to be diving into the engine room of modern technology, data engineering. Our guest, Chris, has been building and leading data teams for decades, witnessing firsthand the massive changes in how organizations handle data. We're going to explore the evolution of this crucial role, the technologies driving it, and where it's headed next. Chris, welcome to the show.
Thank you, Vivian. Thank you, Renee.
Welcome.
So we're going to dive straight into it. Chris, you have been in the industry for almost 2 decades, and the term data engineer has obviously evolved, and it was likely not existing 2 decades ago. So what is the fundamental difference between the historical role and what a data engineer is required to do today, specifically in a modern organization?
Yes, data engineering, it's true. Even the terminology didn't exist. I wouldn't even say it barely existed. It actually was never there.
Yeah.
You had software engineers, you had database developers, and I've seen the shift come from what I refer to as data janitors to data product owners.
Okay.
By that I mean there's been a shift from being reactive to being proactive. So from a database developer perspective, you found that it was about fixing after the fact.
Okay.
Well, then we've shifted to being proactive and looking at how the outcomes will look like before we actually even deliver them. So data engineering has brought that shift from data janitors who are reactive to data product ownership who are more proactive and thinking about the outcomes of the data pipelines that they're building. I think conceptually, that's the evolution.
Yeah.
That has led to the realization of roles like data engineering. Yeah.
Yeah, and I think to your point, I guess one of the key drivers of that also is the technology, right? So the more the technology became more accessible and also a little bit more performant, it allows this transformation from being reactive to be proactive.
Yes.
Yes. Yeah.
Yeah, and I think as well, with the role changing, it's probably as a result of the data changing itself, right? We didn't have the same data that we had a decade ago. If you think about how data used to be very structured, neat tables, like you said, the janitor had specific things that they had to do, but now we've got unstructured data. So how is it that data engineers of today can actually handle this immense variety when it comes to the types of data they're dealing with, as well as understanding the skills that they need to now acquire or at least have to succeed?
Yeah, it's interesting you've mentioned the data, how it has evolved over the years. I believe that the data we see today was always there.
Okay.
Structured and unstructured. It was always there. We just didn't have the tools and platforms to capture it. So we had more tools and platforms that could capture the structured data.
Yeah.
We didn't have tools that could process or capture unstructured data.
Okay.
Unfortunately, because we never captured that unstructured data, we'll never know what was in it.
Fair enough.
But now we've got the platforms and tooling that can capture unstructured data. However, when we think about that explosion and the tooling and the skills needed for that, I believe that the fundamentals haven't changed. The fundamentals of how you look at data have stayed the same. The insights the decisions that you make now are similar to the decisions that you would make previously. The change is the speed of decision making,
Yeah.
the ease of decision making that has very quickly evolved because now you've got more information that you can derive from unstructured data that you couldn't derive previously because the tooling did not exist.
Yes.
So when you think about the skills and the fundamentals, the tooling has changed, the fundamentals have stayed the same. It's around system design for a data engineer. It's about reliability, it's about scalability. Those skills are still very relevant. Back then they were relevant. Now they're even more relevant as you go into a proactive approach. Yeah.
Do you also think, like you just going back to what you mentioned, do you think the the additional level of complexity that business always trying to look into? So if you think about
Streaming.
not streaming, but more about like like back in the day, my first job when I first got to Australia, I used to work for this company that could provide to the stakeholders and their customers vision of their customer, that the stakeholder customers across banking, social media, and purchasing behavior.
Yeah.
So because you have all these 3 layers and each of them has sub layers that requires a whole bunch of like data matching, merging, and linking, it becomes extremely, it's not just now like just one dimensional. You now have like multiple layers of information that you can present to get the insight you're looking for.
Yeah.
It's a good point. And what you're talking about, Renee, is probably the reason why we've evolved into the ELT world.
Yes.
We had the ETL world where you would transform before you land the data. Now you just load everything into a data lake and think about the transformation afterwards.
Yeah.
It's because of wanting to capture all that first, invest the energy into getting all the data as much as you can, and then correlate it together. Because it's coming from disparate data sources, systems that you probably have very little control of, and you want to bring it into a central location for what I would refer to as cross correlation between system sources that you would probably not even have thought about would be correlated. So I think the evolution into ELT, having to think about let's just extract and load everything and then transform to derive insights, has come about because of what exactly you've just said.
That's right.
Yeah. So effectively we're saying the data is the gold, and so organizations want
hasn't
to
changed.
collect as much as they can, and now that technology has evolved, we've got more storage, we're not limited by storage.
That's right. It's become cheaper as well and faster to process it. I think that's why some sectors say that we've captured more data in the last 2 years than we've captured in the last 10, 15 years.
Wow.
Yeah, it's been exponential.
Yeah. And then in terms of, like you mentioned, the principles haven't changed or the fundamentals haven't changed. When you're leading large data teams, how do you approach training and development to make sure that you have your engineers focusing on the essential knowledge, and then there's obviously the nice to have technology or knowledge in that technology areas?
Yeah, I think of it from 2 aspects. From an individual perspective, so I've built teams before, built and scaled data teams before, and what I've found to be valuable is, regardless of the industry, regardless of the organization, is there's a T-shaped approach you can look at when you are trying to build skills in a team or in an individual, or when setting up their career development plans. T-shaped meaning that you want them to, just the way the shape of the T looks like, you've got horizontal and then the vertical.
Yeah, so,
Yeah.
so
The depth.
breadth, more breadth, and then maybe depth in one
Yes,
specific element.
exactly. Yeah. So the vertical piece is the grounding. That's where you want the individual to be strong in SQL skills, for example,
Okay.
in data modeling, those things that will never change regardless of the platform you look at.
That's true.
And then when you look at the horizontal, it's the breadth of platforms. What tools should I be working with? What other areas am I impacting as a data engineer? Because now as a data engineer, if you're going to be proactive, you cannot work in isolation. So you have to be cognizant of the breadth, and that's how the T-shaped is formed. And so when I think about the other second part, it's about the patterns and tooling that the person can work with. So from a pattern perspective, are we going to be streaming? How are we going to be streaming data? Are we going to be batch ingesting data? How are we going to manage schema evolution, for example? Data does mature. Data does change over time. And the data source has to change over time. Does the individual know how to work with slowly changing dimensions, for example, where you track history of how data has evolved, and if you can go back into history, how did data look like? Those skills matter, but they do not care which platform you apply them on. In fact, the limitations will be in the platform. It's now about the individual has got the skills, but the platform probably is limited. And trying to decide now which tooling is relevant is part of the horizontal picture of the T-shaped individual.
Would you? So now, if we start going with the like looking at letters, so T, breadth, depth. Would you say maybe like there's like an M? So like still depth, breadth, but then you have. Would you say it's possible to have someone to have the M, or maybe like pi,
Depth
like
in multiple.
Yeah.
like and to maybe depth into like two, like to what extent the data engineer needs to have depth? So like is it 2, 3, or just one is already enough?
So it's a good question. It's possible to have an M, because now you find that the field is becoming niche. So I guess the depth, the distance in
The
depth
distance,
might be different.
That's right. Yes.
Yes, some depth might be deeper,
yes.
others might be shallow.
Yeah.
But because the field is becoming niche, now you would have data engineers that are just focusing on, say, analytics, or data engineers that are focused on building pipelines for ML, or data engineers that are now just going to be focusing on supporting AI and
Or
large
platform-
language.
or
Yes,
platform
exactly.
engineers, yeah.
And platform engineers. So the depth might be different, but you would find that there will be those might be unicorns as well,
Yeah.
that have got that level of expertise in depth. Yeah.
That's right. Yeah. And I guess like the one thing that I see, it's just basically the depth, the depth of the depth. How can I say that? The deeper the depth is, the better. But at the same time, there are fundamentals that allow people to be able to be fluent enough. I mean, that's the reason why you have the the line on top, right? So you can go as deep as you want to in a specific area, and like.
So at
it's
what,
just-
I suppose maybe the question would be then, at what point does one focus on the depth versus breadth? So like, is it that at an earlier stage within your career, you focus on being more of a generalist, if that's a term within data engineering, and then once you've gotten those basic core fundamental principles, let's say, you would then seek to specialize, but first you have to be a generalist.
There's a bit of tension, I think, that exists when an individual is starting out their career, sometimes their career might be predetermined by the industry they start in, which might restrict them to where they focus in depth. You know, in some if somebody starts out in a consulting environment, you might find that they start off with a generalist approach, while in maybe a corporate organization, they've got their role cut out. They've got their role defined, that this is your area of work, and so they'll probably build out the depth first. But then that will determine their long-term career plans, you know, that because that's their area of comfort. They'll think that's the way to grow. However, that can limit you in flexibility if you get bored quickly and want to explore challenges across multiple industries. And that's where now multiple depths help those that get bored quickly, because then they can be exposed to multiple industries. And they are also the ones that make up the greatest consultants, because now they can talk to anybody and have a conversation, a rich conversation, depth or shallow, but they can still flourish.
Yeah.
Awesome.
Perfect.
Yeah. So we've covered a bit in terms of the tooling. So beyond the tools, so architecture itself has changed. So we've seen a powerful shift from, like you said, traditional batch processing to a demand for real-time data streaming. So in practical terms, how has this industry shift to real-time everything altered your core expectations of a data engineering team, and what are some of the key technical and operational challenges this transition creates?
So the real-time challenge, I've viewed there's been an evolution of what I would term as before real-time or before streaming became very accessible. It was just about landing the data. So it was about eventual consistency, that, okay, have I landed everything? And that's it. But now we're moving into an operational consistency whereby I've landed the data, now what? You know, what else do I need to look after? So if we take the streaming challenge, it's an ongoing monitoring perspective. You know, the data is flowing and never stopping. So you have to think beyond just landing the data. You know, how am I going to monitor this? And if something does not go according to plan, how do I get to be informed? Who do I inform? How do I recover from the failures? And how do I even measure success that this is delivering what's supposed to deliver? So those are kind of soft skills type of requirements from a streaming perspective that would be required for data engineering to think about that. Look, we've shifted from eventual consistency now to operational consistency. I've always told my teams that your success is measured in BAU. It's not about how great you built the solution. It's about the end user.
How does it continue working
Exactly,
afterwards?
100%.
Yeah.
So the end user wasn't there when you were building it. But what they get to experience is after the fact, after you've built it. That is why operational consistency matters. And that is why having the right metrics to measure success or to track and monitor operational consistency also really matter. So that becomes critical with streaming. But I want to caveat that not every industry has got the opportunity to look at it from that angle. You know, there are some industries that will just do fine without streaming, while others, it's business critical. Financial services, banks, it's streaming. You know, telcos, they've got a lot of streaming data. But in some other organization, just batch processing is sufficient.
Efficient.
In fact, it will answer over 80% of the use cases.
So then how do you effectively balance between these newer platform engineering capabilities and the more traditional pipeline skills when structuring and building high-performing teams? So you talked about, you know, batch processing might be efficient or sufficient for one industry, not necessarily for another.
Yeah, you have to start with the business in mind. And it's not just about, hey, I'm a data engineer, I know how to build pipelines. It's also about understanding that, okay, where's the pain point for the business? And that's what I'll start with. If it's batch, go and start there. If it's streaming, go and start there. So put your passion aside. go and solve
the real problems,
the real business problem,
the bread and butter problems.
Because what that does, Vivian and Renee, is it also buys you time to go and pursue your long-term objectives. So it's a two-speed approach.
Yeah.
If you can solve today's pain point, maybe it's a streaming challenge based on where the business is suffering the most. And if that's not your area of passion that you want to solve for, but at least you've solved that, you can use that as a vehicle now to motivate to build the long-term approach that, okay, here's something that we have solved now. It's a streaming challenge, but for us to think long-term, it needs to be reliable. This is a proof of concept. So to think long-term, we have to now think about productionization. There are all these things that now you have to factor in. Data governance, and all those aspects to make it reliable for the long term.
And so in your experience, which industry have you sort of seen that's been very fundamental? Because you've worked in multiple industries. You've worked in mining, telco. What would you say has been your experience within those different industries, and how this has played out the most or the best way?
So what I've noticed from industry to industry, it depends on how quickly or how frequent decisions are made. So in some industries that are risk averse, I think time matters. So for example, in financial services, and when you bring in risk, you want to be monitoring for, say, fraud. Yes, fraud detection. You do need to be proactive, close to real time. Real time can be subjective, depends on who you talk to. To some people it's millisecond, to others 1 hour can be real time. But when you look at a customer and you want to pick up issues so that they do not lose their money in financial services, it does need to be very, very close to millisecond detection. So in financial services, it matters a lot, I guess, to think of it in that aspect. In mining environments that or other organizations that work on a shift basis, you find that decisions are also structured that way.
Okay. Yeah.
You have a shift report that is maybe produced after 12 hours. It means that it's still safe to get the data after 12 hours. You have other industries or organizations that will probably want to produce weekly or monthly reports. The slow-moving industries, maybe superannuation. The way I look at those industries or organizations that move that slow in terms of decision making is, for some it might be okay, but a perspective to challenge that approach is, and this was something my first manager taught me when I was starting out my career, that if you're going to produce a weekly report, do you realize that you're losing 1 week to make a decision? So if you're going to produce a weekly report and that's when you make a $1 million decision so that you don't lose that $1 million, what if you could make that decision instead of within 7 days, you make it within 2 days? Maybe you only lose 200K if your loss is 100K per day and you lose 700 at the end of the week. If you make it earlier, you only lose 200. So the opportunity cost comes into question there. So I think no industry is the same, but this is what I love about data engineering, is that it's industry agnostic. You can fit in.
Yeah. So it's quite interesting. You covered, reports weekly reports, monthly reports, and I guess dashboarding can go into there as well. But this is all human consumption. These reports and dashboards are being consumed by humans. But now we see enter stage left AI, and these pipelines are increasingly feeding into sophisticated AI and ML models. So how has this fundamental shift, building for machine rather than humans, changed how data teams approach critical factors such as data quality, and the process of future engineering and the overall design of the data pipeline, particularly when you're thinking of the fact that data quality is I guess it has a higher risk of bad outcomes if it's poor quality when it comes to machine humans
Garbage in,
or
garbage
yeah,
out.
exactly, machines consuming that. So what's your take on that?
Yeah, so love the garbage in, garbage out hasn't gone away.
Hasn't gone away. It's still very much relevant.
And it won't. But look, you're right. So there's been a shift from analytics ready to model ready approach. So analytics ready, where you save data to humans, now you're going to be saving it to models, the non-humans, to look at it. A human would understand saving the data probably poor quality, depending on the expectations you've set with them. They know that, okay, my data here is only accurate to this certain level. Maybe the cleanliness is only about maybe 75%. And they'll know that, okay, there's a 25% risk that I'm taking here when I make decision based on this data. Unfortunately, when you save the data to models, it only amplifies the issues. The model will take whatever you give it,
As 100% accurate.
So the data quality now matters more when you save it to models, because they will not push back. Look, AGI will come later. Maybe the models will be able to push back that, hey, the data you're giving me
It looks a bit dodgy.
Right.
Exactly. But right now, they'll take whatever you give them. For example, if you save the data to an LLM, I mean, we've seen when you're interacting with an LLM and it hallucinates, and then you
Yes.
correct it, it apologizes to you.
Prompt.
Exactly.
Yeah.
But it can keep going down a rabbit hole depending on the context that you've given it. So data quality does matter more now than
Yes.
before, because the reasoning piece that a human being will apply on poor quality data is not yet there in the models that we are working with right now.
So then how do we solve for this data quality issue?
Yeah. So working with what we have now, so this is where data governance matters mostly. Working with what we have now, it's about building trust in the data pipelines. How do you do that? By increasing visibility through lineage. There's a lot of tooling that can surface that information up. That, okay, where did this data come from? How was it changed? How was it transformed? Who touched it? When was it touched? And does that even matter for consumption? Sometimes yes, sometimes no. But bringing improving the trust levels. That's one aspect. And then there's the evaluation side of it as well. That, okay, we know no data will ever be 100% perfect. But what are the guardrails that we put in place? Now we're talking about AI and LLMs and creating what are known as AI judges, which are inspecting the outcomes of what an LLM has put out. That, okay, what are the guardrails we have thought about? The problem we still have, or the bottleneck we still have there, is the evaluation is based on human input. It's based on the possibilities you've thought of. What about the possibilities you haven't yet thought of?
Yeah.
How do you put them in the evaluation? How do you create this judge that checks for that? So there's that limitation. I think we're close to closing that gap, but it still exists today. So working with what we have today, I think you can look at it from that angle. There's another angle to think of it is customer versus internal use cases. You want to build confidence internally first before you put anything out for consumption to any customer. So I think building internal confidence, knowing how it's working before you put it out is critical as well.
And just to expand on the point you just mentioned, the internal versus external. In our previous episode, we spoke about cross-functional governance, because now we're talking about data, but that was cross-functional AI governance. But the principles seem to be applying to what
the
you're
trust,
describing,
yeah.
right? So building that trust internally also means that you now trying to create an environment where the input is not only coming from the data team, but when it comes to assessing the quality of the output the data we're producing, it now
Yes.
becomes a cross-functional organizational
Input.
Yes.
input, right? So finding ways to get inputs from
Yeah.
different departments within
The human feedback loop.
yes.
Yeah. And it's as simple as putting a like, right, on the outputs that, okay, did this solve your problem? Yes, click the like button. That's
Yes.
feedback loop that goes back into the models and informs them that, yes, this was the safe outcome as well. Not just correct, but was it a safe outcome as well?
Yes.
Yeah.
Great. And I think that kind of opens up to, the next question about what traits does a good data engineer have versus a great data engineer? Is it the specific technical depth? Is it business acumen? How do you balance the two, and how do you mentor engineers to think strategically about the data's overall impact on the business,
I guess
like what we were touching on now?
I guess maybe to rephrase the question, and correct me if I'm wrong, Vivian, are you asking engineer versus senior engineer versus
No, it's
engineering?
more of a good data engineer and then a great data engineer. How do you differentiate if they're at the same level? They're both seniors, or they're both just engineers, or
Oh yeah, okay.
Yes.
how do you differentiate between a good one and a great one?
Yes.
Specifically looking at the technical depth that we discussed
Yeah.
earlier,
The
and then the
T-shaped
business
one.
acumen and
Yeah.
how to balance
Yeah.
the two. And then if you're mentoring your team members or engineers within your team, how do you then mentor them to think strategically about what we were talking about now, the business impact overall?
It's a great question. The difference for me between a good engineer and a great engineer.
I feel like your team will be like, oh crap, this is what I need to do to be better.
Yes, they need to watch this episode.
This is gonna sound very counterintuitive, but a great engineer for me is one that works themselves out of the job.
Interesting. Okay.
Demand for data engineering is increasing. We see it everywhere. Data engineers can be a bottleneck to the data value chain. Data engineers source the data. So for me, a great data engineer is one that works themselves out of the job. What does that mean?
I like it. I actually like it. Before you carry on, I like this. I think I know where you're going. I just don't want to, I'll leave it to you.
Yeah.
Maybe I'll add a few things, but I like it. I like where you're going with this.
The great data engineer will build for self-service. They'll build platforms and solutions for others to build on. No organization will ever hire all the data engineers in the world. So one engineer has to think beyond themselves to create, and they are an enabler. So they will enable the business, and they will build self-service solutions or platforms and tools for others to build for themselves. One engineer can never build for all use cases. So they have to be very agnostic. They have to be very agnostic and build reusability in what they deliver. What does that take? It means that the engineer has to build an abstraction layer to hide the complexity, so that it's easier for the others that build on top of that. Because complexity is what blocks self-service.
That's true.
So a good data engineer, so I've described the great data engineer.
Yeah.
So a good data engineer is everything below that. So that is somebody who will want to build everything. That
Everything must be bespoke.
Yes. Everything must be bespoke. They're not thinking about the opportunity to just buy. They're not thinking about the opportunity to just integrate existing tooling. You know, they are thinking about just their pipeline. They're not thinking about, okay, the data that comes out of the pipeline, who is it going to impact? What's the business outcome of what I'm delivering? You know, if the source system changes, how is it going to impact my pipeline? So they're just thinking about their data pipeline. That's a good data engineer. Yes, they know how to build the pipeline, which is good. But from good to great, it's about all those things that I just mentioned earlier.
So that's return on investment, effectively.
So that data engineers out there, you know what to do if you want to get promoted.
Yeah, exactly.
You want to get a promotion, or just like you said, like move on to the next big
level.
thing, which is not necessarily within the organization you're working for.
Yeah.
I like that answer, because I think there's at times, especially when I think about me not having been to the engineering, professional path like everyone else. I came from a data science and so on. You come in with a different angle. So when I build things, it's in mind that you want to make it reusable. The challenge, however, that I see with that is it at times the value to the business is not necessarily upfront. So a lot of people will say, why did you waste your time trying to build this abstraction layer when we asked you to just deliver on the pipeline, right? And that's when things start to become a little bit, a bit difficult to manage. I think it's up to the engineering manager or whoever is, above, to be able to understand the value that is being created through that process, and understand that it's setting up the team or the company to
That future-proof.
Future-proof,
Yeah.
right?
Yes.
So I think that will be my question to you now. Like, how do you manage
Those expectations.
those expectations? Because I'm sure, 1 out of like 4 data engineers would think about, how do we build that in such a way that it becomes reusable artifacts for the business? The problem is, like, when you think about it that way, some people
buy-in from the business.
the buy-in from the business, and at times it looks more like what you're building doesn't necessarily meet the KPI of that quota or the BAU that data engineer is working on. So
it's a valid concern, and I see it a lot. I've seen it a lot over a number of years. Expectation management is really critical. There's a bit of friction between. So if you look at a data engineer that's starting out their career and wants to show that they are great, but also does not want to hurt the end user's feelings. They just want to be nice, and there's nothing wrong with that. That works against the strategy around expectation management. There's no secret to expectation management. There's only one formula around it. A lot of people won't like this, but you just have to under-promise and over-deliver. But that under-promise does need to meet the minimum expectation.
The MVP one.
Yes. Of the business. That is why it's important to start with a small pain point. Solve that, then go and scale. So solve the small pain point with scalability in mind. The business will be happy, the business user will feel like you've solved something for them, you know, and then use that as your way of managing expectations. So you've solved that small piece, you've delivered the minimum requirement, and now you can use that as your way of scaling to go and exceed expectations, because the goal shouldn't just be to meet expectations. It should be to exceed, expectations.
Yeah.
You don't want, you want to be smart. You want, so smart, I mean the capitals, smart. You want to be delivering a goal that is smart, that is realistic, achievable, you know.
Measurable.
Yes, exactly. So to do that, you cannot set an expectation that is unachievable for yourself. So that is what I mean by under promise. Set an expectation that you can exceed, but is also what the business user or a customer expects at the minimum. Yeah. Now that is a challenge for somebody who's starting out, but somebody who's been around for a while, they've learned it over time, they've seen multiple scenarios, they've become comfortable to having difficult, to challenge and have difficult conversations. It becomes easier over time. So it does require a bit of coaching, you know, to coaching the engineers to get to that level for them to feel comfortable. So that's natural. Yes.
So effectively, when it comes to how you mentor engineers, you just expose them to those difficult scenarios as
With
a pressure
guardrails.
test with guardrails.
With guardrails, because
Yeah.
they have to feel safe to fail, you know. So they have, I have to set up the environment for them to safely fail. Those are the guardrails. Yeah, expose them to those environments.
Yeah, I like it. I think the my takeaway on this is be smart even how you set the expectations, so that in your quest to deliver on the outcome, you're still also adding that extra bit that you have in mind that helps to now be able to scale the solution to the point where you don't have to come back to this. Like, so if there's any challenge, it's not something that will come back to you. It's you've kind of already find ways to solve that problem in a way that many part of the business or any touch point can just plug into your solution and just, so you kind of automate. It's almost like doing a bit of automation, right? So okay.
Yeah.
Speaking of automation, though, so looking ahead, there's all conversations around automation and the role of AI within our jobs. Based on what you're seeing in the market now, what your teams are experiencing, how do you project the data engineering role evolving over the next, let's say, 5 years? And what are some steps you would be recommending, whether to your team or to any other current engineers out there, on future-proofing their careers and staying relevant?
Yeah, so with the coming of AI, we've all been disrupted in the last few years. Ways of working are changing. Data engineering is not spared.
Yeah.
The fact is that AI is going to automate routine tasks, but will create a demand for high level of thinking. So as data engineers, we have now to start thinking about that. What's that higher level of thinking that I need to build myself into? So this evolution is not new, it's just different tooling and technology that has emerged, but the high level of thinking has always been there. What that means as well, again, is what tools can I now use to put together and intelligently deliver my work? So the next phase of a data engineer, I think, is evolving into, we probably don't have a name for it yet, but if we were to put together words that we know today, that might be very wrong in future, as in irrelevant, but putting together words that we know today so that it makes sense for anybody to understand, it's around maybe a data systems architect, somebody who's putting tooling together. That higher level of thinking requires reasoning, which we haven't yet seen to that extent. This is why you find, say, in agentic AI, you have these specialized AI agents that are doing stuff. Somebody has to think about orchestration. Somebody has to think about what tools are they going to use, where are they going to source the data from, what context should I provide to them. So context engineering coming into play beyond prompt.
Yeah.
Prompt is no longer sufficient. You have to think about context. So I think to future-proof yourself as a data engineer, you have to think about what higher level of thinking am I now going to give the world of AI, because it's evolving. And when I mentioned that this has always been there before, I always go back to the switch from horses to vehicles. There were people that whose job, or maybe even an industry, just for horseshoes. They are probably the same. So those that were happy with the transition to cars learned how to repair tires. That was higher level of thinking that, okay, now how do I position myself to do the higher demand work that is coming up that requires a bit more reasoning. So this is a repeat, just that we live in a different world with different tooling and platforms, but the transition
concept.
We've got a lot of examples to look at. Yeah.
Awesome.
Yeah, very nice. And I think going back to data engineering, and you said the whole automation piece. I know for a fact that some of the engineers that I've seen out there working on even that migration from like an ETL type of environment to an ELT, converting all these Informatica, how do you call that? Processes? How do you call that? Like
transformations,
Informatica transformation into, I guess, Spark, SQL, because now if you move into your ELT, the data will be sitting somewhere, but it has to be now processed to be loaded into the data warehouse. So how do you now map those Informatica processes into scripts that will be loaded into the data warehouse, and they're using AI for that, right?
Yeah.
So, that's a massive piece of job. But now that you have AI, it helps you to accelerate that process, right? So,
And however, though, there's going to be people that, think the way you're thinking, Renee, about it. There will be also engineers that think that they want to replicate how things work today into the new world. I think those that think that way might be bottlenecked because they are trying to replicate an old way of doing data engineering.
That's true.
With the new platform. So I think they have to think like what you've described. And that means that they will, so those that will think like what you've described, Renee, will think and challenge the status quo that, what if I don't need to move the data? What if the data could just stay where it is and I still get to the same outcome?
True.
Because what's the point of data movement if you can still get the same results? So right now we've seen how AI is evolving and the integration toolings that are coming up. I mean, Anthropic have released Model Context Protocol, which allows you to integrate. And you can grab context through that, save it to a foundation model, and then orchestrate the results. That's still data engineering. And you get to the same outcome. Guess what? The end user doesn't see all that. It's the abstraction. But what you just did was you saved your business on costs. You didn't have to run infrastructure to transform the data. And you've shortened the turnaround time. You've shortened the data journey. You've also ensured that your governance is in place because you didn't move. If there's PII data in the source system, you didn't move it. It didn't leave. So if there's security in the data source, it's still intact. So
do you think the data migration at some point, would it be obsolete or? Okay.
And that's usually I suppose a limiting factor, like you mentioned, when you're dealing with data that is personally identifiable information, where you can't move the data to certain locations in the world. So that would be a real game changer for a lot of organizations.
Yeah, I don't think data migration will be a thing soon. If I'm allowed to make a prediction,
Yes, of course.
I think that's one thing that will disappear. There will be no need for data migration.
Interesting. Yeah, I can see that happening. But yeah, I think time will tell.
Yeah, time will definitely tell. And I think it also highlights what we talked about already, the good versus great. Being a data engineer that's able to actually think that way and challenge the status quo. But
Yeah.
Chris, thank you for clarifying the state and the future of data engineering. It was a pleasure having you on this episode.
Yeah, it was a real pleasure. I think I learned quite a fair bit, and I also reinforced some of my thinking already, because having been a data engineer from a career perspective, but now being an AI engineer, I still do some stuff with data. I can see like some of the comment and that you mentioned throughout this episode. Feel like are very much relevant, and I think I guess my only takeaway will be, well, not my takeaway, my advice to the data engineers out there wanting to get into AI. It's not like you want to get into AI, it's how you can bring AI into your world, right? So it's not a matter of like, oh, how do I become an AI engineer? It's how do I use AI? So now they have to go into the homework and try to see the bottlenecks, the areas where they can move from good to great. Maybe the great means that you're bringing the AI piece into the data engineering world, and it allows you to now be able to unlock a few things, maybe move faster. So that means like when you have that lower expectation you set into the business, you basically just go out there and become, like a superhuman, because we already had an episode where we spoke about how with AI we're becoming superhuman. You become a super data engineer by just not necessarily delivering on the piece that you promised, but you expanding a bit more and allowing people to, like easily, instead of having to go and write SQL scripts, they can just like type words, and then the agent will go and pull the data that they're looking for, and then it's created visuals already, and everyone is happy.
Yeah. Any final comments for our listeners?
No, I think this is it's been an opportunity for me. First of all, thank you very much for having me, and I would encourage, if there's any data engineer looking or to progress their career, they are still, so with the coming of AI, they are already doing what they are required to do. They're in the right place, so they shouldn't feel left behind, or they already know the principles, the patterns that AI needs. So they already have the fundamentals. I think that's my message to the data engineers. But thank you for having me. No problem.
Thanks, everyone. See you next time.
See ya.